In our previous session, we looked at this fashion dataset for object detection. We also went through these folders right here, which contain the dataset images and their different annotations. In this session, we're going to dive into using a tool like RemoAI to create such datasets. So firstly, we learned we understood the dataset which we're going to be using, and now we are going to be able to create our own dataset. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. Remo is this amazing platform which permits just anyone create and manage image datasets. With Remo, we are going to be able to create our own object detection dataset with very minimal effort. So that's it. Let's get straight into installing Remo. So first things first, we're going to install Remo by using this command pip install Remo. We open up the command prompt and we have pip install Remo. Once we have this installed, we'll then go ahead to initialize the Remo app. So we have this init, and then we're going to launch the app. So let's take this off and we launch our Remo app. You should note the login and the password, which we're going to use right here in this launched app. So we put in our email and the password. There we go. That's fine. We have previous data sets which we've created, and now we could create our new data set, which we call fashion data set. So we have our fashion data set right here. We creating data set created successfully. Click on this. You could have this here. You see different settings. You could rename, duplicate, export annotation, or delete. So that's it. So let's click on that, and there we go. So we're gonna go ahead and add some data. Here we're gonna import only images because that's practically what we have. We don't have images and the annotations already. So here we just add images, and then we're gonna use local data. So here we have upload data, use local data. Now we're gonna browse files to upload these images. There we go. We select these different images. We have this 10 images which we downloaded and which we're going to use now as our custom data set. So right here we click on open. They've been loaded, and then now we could upload. So while it's uploading, we can start viewing these 10 items which we just added. So there we go. We have them. You could zoom in. You could reduce this or increase the size. So that's it. Here are all the different items. You should know that in practice, that is, if you're trying to solve a real world problem, you will not have just 10 items. You have tens of thousands, hundreds of thousands, and even millions of items. But to show you how these kinds of data sets are created, let's just consider these 10 items. So that's it. We could again add data, or we could go straight to annotations. So let's click on annotate, and we'll have here type the name of the annotation set. So here we'll call this fashion data set annotations. There we go. So select the task, object detection. Optional, you could add classes. Now let's get back to our list of classes. Here we have sunglass, hat, jacket, shirt, pants, shorts, skirt, dress, bag, and shoe. So we're gonna add all these classes in here. Although that's optional, we could do this later on, but let's just do that now. So here we have sunglass, hat, jacket. We add, and then hat. We add, and there we go. We click on create, and we find your fashion dataset annotations. Let's go to annotate, and that's it. So we click on this, and we should have this page pop up. And then from here, you can see you have the list of all the images which make up our dataset. So here we go. You could check out on all these images. And then here, our explore tool, you see, we could go through our image, and then we could start to annotate. So you see, draw a box. So here with this, we could draw a box. Now you'll notice here, let's zoom this. You notice here we have this image, or rather this sunglass. So already we have this sunglass, and we could draw a box. So let's click on this and draw that box right there. So we draw this box, and that's it. So that's our sunglass. And now you just have to select. So you just here select sunglass, and you save that. So that's fine. Now you could go again. You could use the hand tool. So you could drag it this way, and then the next one you have is this shirt right here. So let's have this again, and there we go. So we have that, and then there we could type in shirt, that goes. And then now we move to the next. Next we have pants. So here we take this right here. You notice how easy it is to actually get to this point. So basically, when you want to draw the bounding box, you just have to get to this top left corner of the object, and then you click, and then you go downward. So you go down, like you go to the down right corner, so you go this way. So that's it. There we go. We stop at this point. So now we have pants, and we save. Now next one, we scroll again. We have this time around. So just like we saw in the previous session where we had this two combined as one shoe, we could do that this way, but we want to consider that this is just one. So here we go. We have this as one shoe. Let's get back to this. Let's take back and then redo that. So here we have this as a shoe. Click on this, save, and then the next, there we go. Click on this again, and then take this. You see, you could start from the bottom right corner and go towards the top left corner. So let's have this. We go this way, stop right here around this. Okay, and then we have a shoe. Click on that, and that's fine. And that's it for this image. We see we've annotated our image, and now we could click on done. So we mark this as done. You'll notice that once marked as done, you have this tiny green line right here, unlike here where we have no line. So we move to the next image, and then we proceed with annotations. So here we have that, and then we click this, no sunglass. We have pants. So here we have pants. There we go. Pants. Click on this, save. Next one, we have annotate shoe. Click on that. We have shoe. There we go. Next one, click again on that, and here we have shoe. There we go. Now for this next one, which is a top, we are going to take this here and then specify that we have a top. So we have no top there. We're going to create a new class. So we are not going to use only these 10 classes provided by the dataset from Kaggle. We're going to create, or we're going to include our own extra class, which is a top. So we have a top, and then new class. So type in the new class name top, set enter, and then you select. So now we select this, and then we save. So you see here we have top. It should be added in this here. You see we have added a top. So that's it. That's done. So we click on done. You could always click on hold. So for now we have this to done, and then we get to this one, and we repeat the same process right to the end. We've now completed all 10 annotations. You could look from this, and one thing you could do is you could always modify this. So like here, let's click on this draw box, click on this, and then you see we could reduce this so that it comes in exactly as we want it to be. So that's it, and then you click on done. You could see this other annotations, and the next thing we'll do is to export this annotations for dataset. So there we go. We export these annotations. We choose the format. We're going to choose the Remo JSON format. So we click on that, and then we have also some advanced options here where we could modify the data formatting and also what to export. Anyway, we're not going to be looking at this. From here, we select Remo JSON as we said already, and then we export. So we have the JSON file right here, which we want to save to our PC, and then we simply save. You could click on this saved annotations, and there we go. We have these different annotations. You see we have for each and every image, like in this case, we have this image, we have its height, we are given the width, we have the task, and then we have all the different bounding boxes. So here we have X max, X mean, Y max, Y mean, we have the class, we have this, we have the class, and that's it. So you notice that this format is different from the Pascal VOC format, which we've seen already. And so we're going to write some code to convert from this Remo JSON format into our Pascal VOC format. the code in question is made available to you in this Colab notebook. So here we have converting from Remo format to Pascal VOC format. You run this cell, and then you run this next cell. Next you have this. Now here we are gonna specify, or we're gonna import or upload this JSON file which we generated from the Remo app. So here we have this. Click here, and we don't have that for now, so we're gonna copy that or upload that from our PC into this Colab notebook. That's uploading. That's now uploaded, and now you could run this. So here we have with open annotations. So we have to create also this annotations folder. So here's where our annotations will be stored. We have annotations folder created. We ran the cell already, so that's fine. So we run this cell, and that should be fine. So that's fine. Now you open this, and you see that you have this 10 XML files as we expect. We could open one of this, and here's what we're gonna have. So here we have, as usual, the metadata, and then for each object we have the different bounding boxes. We could also verify this, that all the bounding boxes are correct, by simply doing this here. So we have that, and then check out this position, like note the point here. So here we have 222,355, and then here we have 293,97. So this matches actually with this one here. It matches with this one, and then the next one, let's draw this here. The next one we have something like 363, 356 here. That's it. And then this one something like 424, 397. So that's it. So we see that this actually matches up with what we have in the XML file. At this point, we now have all these images with the corresponding annotations, as we could see right here. So we will just copy these annotations like this, and then place in this annotations folder right here. So we paste this here. There we go. And then we also copy these images. So we have these images. We would actually cut. So let's just cut these images and then place in here. There we go. Okay, we have those images. We could delete these ones because we've already copied this. And then here we modify these labels to take into consideration the top. So here we have top. We save that, and that's fine. At this point, we have our data set prepared, and we're set for training our model. One last step we need to take into consideration before going to the next section is splitting our data. So let's suppose we have this data set right here. Currently our data set is about 2,500 different images and labels. So we have 2,500 sized data set. And then if you have to train your model, that's our deep neural network, with all this data, then the question is, how do we evaluate our model? So how do we know how well our model is performing? And so to answer that question, the approach we will use is, before getting into training, we will split our data set. So we would have our training data, and then we'll have the data meant for evaluation, or we could say our test data. So here we have our training data, and then we have this data which is meant for evaluation. We could also further break this training data into training data and validation data. So we could also have this. Now that said, the main idea here is to have data which you will train the model on, and then data which you will also be able to evaluate the model, because actually useless being training a model which we can't really evaluate. Now it turns out that this data set already had been split. So here, if you check out in this image sets, let's open up image sets, main, you have the train val split and the test split. Now if you open up the test split, you'd see you have 537 elements, and if you open up this train val, you see you have something like 2,145 different elements. So here we have 537, and then here we have 2,147 elements. Now this validation here is some sort of evaluation which permits us modify the training process, and this is separate from the test or eval data set. Now with the validation, we could take a simple example. So supposing you're training data and the model starts to overfit. Now this is a very common problem in machine learning in general. So what's overfitting about? So here with overfitting, or in the specific case of object detection, we may have a scenario where our model has been trained on data where the models or the people are facing the camera from the front. So you have this kind of data, but then what if we have now in real world where the inputs is this kind of data where the camera is taking the picture from the side, or you have something like this. You see, this looks quite different from the typical data we'll have from the original data set. Recall that this is the data, this is the data set we just created, this 10 images here. You'll notice that they are quite different from what the original data set had. And so when we say a model overfits, it means the model adjusts its weights or its parameters to suit only this particular data set, whereas the aim of the training process is to make the model as intelligent as possible. And if a model has to be intelligent, then it has to perform as well on this kind of data where someone is seated as it would do on this kind of data which is used to seeing. And so many times models will overfit because they have been shown a particular type of data so many times, and the weights have been adjusted to fit this kind of data. And when now faced with test data or real world data, the model doesn't perform as well as it would have done with the original kind of data it was trained on. So while doing the training, to check and see whether the model is overfitting or not, or whether the model is being biased towards a certain type of data or not, we have to include a validation data set. So with a validation data set, while doing the training, you get to see how the model performs on data it is been trained on, and also how it performs on data it has never ever seen. So this permits the practitioner to take the right measures. But one most important measure to solve this kind of problem is increasing your data. And so if your model performs well on this kind of data but doesn't perform well on this type of data right here, all you need to do is to increase the number of samples which look like this. And by doing so, the model now learns to perform similarly well on this kind of data and also on this kind of data. So getting back here, what we're gonna do is in this here we're gonna include some of our data. Like if we have this data set here, like here we have this data set or this 10 new images. If we have this 10 new images, then we need to include them in here. So in this test, we're gonna include, since we have 10, we are gonna say we want to take 20% will go to testing, and then 80% will go to training. Now this 80% happens to be 8 and 20% happens to be 2, since we have 10 new elements. But in the case where you've gathered or you've created a data set of say 100,000 new elements, then you would have for 20% is going to be 20,000, and then for 80% is going to be 80,000. Now also note that as your data sets become, your data set becomes very large, you could do well with using say a smaller percentage. So you don't need to go right up to 20% for the test set if your data set becomes very, very large. But note that the whole essence of this evaluation process is to see how well the model performs on data it has never ever seen. Now for our test data, we're going to include this year, new data 1, and then new data 2, and then we're going to have this rest for the training. So here we have for training, we have new data 3 right up to new data 10. So that's it. So that's how we include our newly created data set in this original data set. Yeah, we save that, we save this, and we could close that. We're now done with this. See, we get back, and then let's compress this and send this to our Google Drive. Getting back to the Collab notebook, we have this, connect to Google Drive. There we go, this pops up right here. We now have my drive, and then we are gonna drag this our new data set in my drive. So drag this. Uploaded files will get deleted when this runtime is recycled. Okay, and that's even the reason why we putting this in the drive, because once we done with this, we could always access this without having to re-upload the data set from our PC.